Hello students, welcome you all to the next session of computer organization and architecture. So in the last session we have seen about multiplication of positive numbers and signed operand multiplication. So in that signed operand multiplication we have seen mostly of Booth algorithm technique. Okay, so now we move on to the fast multiplication. Uh, First of all, why we are using a fast multiplication technique? The fast multiplication technique is in order to multiply the binary numbers in a fast and effective manner, along with using some algorithm to multiply the numbers within a given specific time. Okay, so mainly the fast multiplication techniques we are using for speeding up of the multiplication operation. So the multiplication technique in this we are using mainly of two techniques. The first one is bit pair recoding of multipliers and second one is carry save addition of summons. Okay, so now we move on to the PPT about the bit pair recoding of multipliers and carry save addition of summons. So in this session, I will going to explain about only bit pair recoding. Okay, so before moving on to this bit pair recoding, I like to share you about a Booth algorithm technique. Already we have seen in the last session how the Booth algorithm works. So wait, yeah, fine. So here, the main technique is used is by seeing the rules. What are the rules? If 0 to 0, 0, 1, 1, 0, and 1, 1. So in the Booth algorithm, first we have to take the multiplier and we have to recode that multiplier, right? So for that, some rules are followed. So we have to see from right to left. If 0 to 0 is, you have to give us 0. 1 to 0 is, you have to give us plus 1. 0 to 1 is, we have to give us minus 1. And 1 to 1 is 0. So simply you look into this rule and you make it as if 0 to 0 means 0, 1 to 1 means 0. And 1 to 0, that is you have to see from right to left. If it is from 1 to 0, you have to make it as plus 1, and 0 to 1 means you have to make it as minus 1. This is a simple rule in Booth algorithm. Okay, so now I am giving a recap of Booth algorithm. So if you concentrate in this, it is easy to go ahead for bit pair recoding. The same procedure only followed for bit pair recoding. Okay, so take this as an example. Already we have seen this example in the last session. Take this as a multiplier 0 1 1 0 0 1. So what is the first step for this Booth algorithm? You have to add 0 to the right end of the multiplier. So I am adding the 0. Since I have added 0, I have given is here in square. Okay, so next we have to apply the rule. So for applying the rule, you have to see from right to left. Okay, so right to left. So make it as 0 to 1. So what is here 0 to 1 means minus 1. So write as minus 1. And next 1 to 0. So what is 1 to 0? It is plus 1. So write as plus 1. And 0 to 0. So 0 to 0 is 0. And next 0 to 1. So 0 to 1 is, what is 0 to 1? Minus 1. Write as minus 1. Next is 1 to 1. So it is 0. And next is 1 to 0. And 1 to 0 is plus 1. So this is a first step for Booth algorithm. Okay. So next we can after continuation of this, after giving a recoded multiplier, we can process like this. Okay, so let us take the multiplier as 0 0 1 1 0 0 and multiplicand as 0 1 0 0 1 1. So can you say what is the first step? So first step is to take the multiplier. So here multiplier is 0 0 1 1 0 0. To perform Booth algorithm, what you have to do? You have to add 0 in this right side. Okay, and you have to perform the rules, that is 0 to 0, will be 0. Next 0 to 0 is 0. 0 to 1 is minus 1. 1 to 1 is 0. 1 to 0 is plus 1. 0 to 0 is 0. And next automatically you have to take a multiplicand and a multiplier, you have to write it. Okay, so first you have to give a normal multiplication, and if minus 1 comes means what you have to do, so you have to take the 2's complement of the multiplicand. 2's complement of the multiplicand. So what is a multiplicand here? 0 1 0 0 1 1. So for perform 2's complement, what you have to do first? You have to perform 1's complement. That is 1 0 1 1 0 0, and you have to add 1. So your answer will be 1 0 1 1 0 1. So here you have to write 1 0, that is from right to left you have to write. So 1 0 1 1 0 1, and you have to extend the sign bit over here. So how you have to extend the sign bit means, if it is a 6-bit multiplier means you have to extend up to another 6-bit. So total 12 bits will be there. Okay, so here in this last one, least significant bit, it is 1. So you have mentioned here 1. If it is 0 means you have to mention as 0. And for plus 1, normally the multiplication process you have to do it. And at last you have to add it. And you have to take the 1's complement, let's call it the 2's complement, and you will get the multiplication answer for this Booth multiplication. Okay, so just remember the steps for Booth multiplication. Wait. So here, the points to remember in this both multiplication is, if 0 to 0 and 1 to 1, no operation will be there. If it is 0 to 1 means add multiplication to the left of the product. And if 1 to 0 means subtract multiplication from the left of the product. That is by using that 2's complement they have mentioned over here. Okay. And next we move on to bit pair recoding. So already I explained what is bit pair recoding. So why we are using. So for fastest multiplication, we are moving on to the two techniques called bit pair recoding and carry save addition of summons. So in this session, we are going to see only about bit pair recoding. So in this technique, it guarantees that the maximum number of summons that must be added is n by 2 for n bit operands. So what does this means? If we are going of 6-bit means, so n by 2. So we are reducing it to n by 2, that is 6 by 2. So 3-bit operands, by using 3-bit operands, we are multiplying with this. Okay, so this is same as that of Booth algorithm, but only one more step will get added. So let us see the rules of this what bit pair recoding. So in the Booth algorithm, we have seen only 2 bits, right? Here you are going to see 3. That is 0, 0, 0 means 0. 0, 0, 1 means it will be minus, sorry, plus 1. And 0, 1, 0 also plus 1. 0, 1, 1 is plus 2. 1, 0, 0 means minus 2. 1, 0, 1 means minus 1. 1, 1, 0 is minus 1. And 1, 1, 1 will be 0. Okay. Let us move on to the example of this bit pair recoding. As I said, so this is a technique that the maximum number of summons that must be added into n by 2 bits. So for example, if we have 8 bits means it will be of 8 by 2, that is 4 bits. Okay. So here, let us take one example of this. So the example given here is 1, 1, 1. Sorry. Yes, 1110100. This is a given example. So let us see in the next slide clearly about the example for this bit pair recoding, the multiplicand and multiplier. Multiplicand and multiplier is there, okay? Yes. So here I'm taking the bit per equal. How is that the multiplier, that is 111010, and I'm adding a right 10. Okay. So we have to take it as 3. In that Booth algorithm, we have took that from the rules from right to left as 2. So here you have to take 3 bits. Okay. So here from right to left you have to take 3. That is here 001, and here 101 and 111 will be there. Okay, so you have to group it as 3 bits over here. So for, look at the table, in the last given table, that is for 100 it is -2. Here 100 it is -2. So look at here, we have given here as -2. Okay, and 101, and look at this table for 101 it is -1. So we have marked here as -1, and at last the leftmost bit is 111, it is 0. So here marked as 0. So since we have a 6-bit summons, so in this bit pair recording, what they will take for 6 bits, it will be of n by 2 bits. Okay, so 6 by 2, that is 3 bits. So 6 bits is converted into 3 bits, that is 0, -1 and -2. So let us write and tell you clearly. Yes. So here, wait. So here we have taken the multiplicand 01101. Okay. And the bit, after performing the bit pair recoding, we got 0, -1 and -2. So the we have to multiply this multiplicand and multiplier. Okay. So in this Booth algorithm, we got only 0, -1 and +1. So for -1, what we will do? We will put 2's complement of the multiplier, and we will multiplicand, sorry, 2's complement of the multiplicand, and we will process it. Okay. So here also -1 is there. So we can perform 2's complement. So if it is -2, we have to perform 2's complement plus 0. So if it is -2 means have to perform 2's complement plus 0. Okay. So here for -2 for the multiplicand. Okay. So first you take the multiplicand value 01101 and perform 2's complement. So performing 2's complement, you have to perform 1's complement, right? So you have for the multiplicand. So it will be 1 0 0 1 0, and you have to add 1, that is 1 1 0 0 and 1. This is 2's complement, right? We have performed 2's complement. And for -2, what you have to do? You have to add 1 to the 2's complement. So you have to add 0 to the 2's complement. So what you got? 1 0 0 1 1 0. So write it from right to left. 0 1 1 0 0 1. And you have to extend the sign bit. Since it is a 6-bit, you have to move on to 12 bits, right? So 1 2 3 4 5 6 7 8 9 10. So sorry, it is a 5-bit. We have to move on to 10 bits. Okay. So here I have given us one, we have written 0 1 1 0 0 1, and you have to extend the sign bit over here. And next, -1. So -1 is normal 2's complement. So what will be the value? 1 0 0 1 1. So here 1 1 0 0 1, and you have to extend the sign bit. And next is 0, so you have to give us 0. And next you add all the products and you will get the value, that is value of this multiplicand and multiplier. So this is very simple and fast. We are using bit pair recording for fast multiplication of the operands. Okay, and we have another one example over here. So they have a multiplier. So normally you have to take a multiplier and perform the, I think they have given here as, yeah, Booth algorithm. We have given here Booth algorithm. Okay, so normal multiplication, that is take the multiplier, add 0 over here, and then have to perform the recoded multiplier, and -1 means 2's complement, +1 means normal thing only, and you have to add it. So what is the difference between Booth algorithm and bit pair recoding is, so the technique which we are using in this bit pair recoding is to reduce the maximum number of summands. That is, if that is the about the bit, if it is n bit means it will become to n by 2 operands. Okay, and the step also, product also will get decreased, and it will be in fast and effective manner. So here I have given the rules for bit pair recoding. So these two is an important rule for bit pair recoding. What is the rule? If multiplier is -2, find 2's complement of the multiplicand and include 0 at the end. So what we have done in this problem. So if it is a 2's complement, -2 means perform the 2's complement of the multiplicand and add 0 at the end. And if multiplier is +2, include 0 at the end with the multiplicand. That is, no need to perform the 2's complement. So directly in the multiplicand, you can add 0 if it is plus. So only these are the main rules for bit pair recoding. So I think you are clear with this bit pair recoding. I will repeat the procedure how to do the bit pair recoding. You have to take the multiplicand and multiplier value, and in that multiplier value, what you have to do? You have to what uh, produce the recoded bit. That is by 3 bits. You have to take it as 3 bit and you have to perform. And from this also, from right to left, you have to verify it. That is 0 0 1 means -2, 1 0 1 is -1, and 1 1 1 will be 0. So if you're familiar with the table, if you can go through the table once or twice, it will be easy for you to write this bit, perform this bit pair recoding. Okay, so first after doing this recoding technique, write the multiplicand, and next write the recoded one, 0 -1 and -2. Now you check on these rules. If the multiplier is -2, what you have to do? You have to perform the 2's complement of the multiplicand and include 0 at the end. If it is +2 means what you have to do? Include 0 at the end with the multiplicand. Okay, so in this problem we have the cases -2. So what do you have to do? Tell me. So what you have to do? You have to take the multiplicand and perform 2's complement of multiplication and add 0. So here 1 multiplicand is 0 1 1 0 1. So 1's complement will be 1 0 0 1 0, and perform 2's complement, add 1. So your value will be 1 0 0 1 1, and also you have to include 0 at the end for -2. Okay, and you have to write it from this right to left, and you have to include the sign bit. Here the last that is least significant bit is of 1, so you have to use your, have to extend the sign bit as 1. So next for -1, so you have to perform the 1's complement and you have to do it, and next is 0. sorry, for a -1, you have to perform the 2's complement, and x is 0, so all will be 0, and next you have to add it. This is a simple process which we are using for bit pair recoding. Keep that in mind. In forced multiplication, we have two techniques. So the first one is bit pair recoding, and second is carry save addition. Okay, so in this session, we have mainly concentrated on bit pair recoding. So if they ask for forced multiplication technique, you have to write about bit pair recoding of multipliers, and next technique is carry save addition of summons. We can see this carry save addition on summons in the next section. Okay, I hope you are clear with this bit pair recoding and Booth algorithm. So just you look on to the rules of these two, Booth algorithm and bit pair recoding, and look on to the table once you have go through the table. If you are clear with the table and rules, it will be easy for you to perform these two algorithm. Okay. Thank you so much.